Hello, and welcome to PodRocket. I'm Kate, the producer of PodRocket. With me today is Evyatar Alush. Hi, Evyatar. How are you doing?
Hey, doing fun. How are you?
Thanks for being on today.
Thank you for inviting me.
Also with me is Noel from. He's been on a lot of podcasts lately. Thanks, Noel. You've been crushing it. um, uh,
No problem. No problem.
one of our engineers at LogRocket and one of our hosts on the PodRocket team. So Evyatar is the creator of Vest. So if you wouldn't mind just telling us kind of what Vest is, and we can get started from there.
Yeah, sure. VEST is a form validations library. It's a declarative form validation library. And it draws its syntax and style from unit testing libraries like Mocha or Jest. So if you've done some unit testing in your JS apps, you'll feel very much comfortable using VEST, and it will be very similar and very familiar to you.
Nice. Very cool. So, like, I guess I've looked at the doc. I've looked at the docs and stuff. I feel like I've got a pretty good handle. But one thing that confused me a little bit when I started reading, in my understanding, was like, yeah, Vest. It says it claims to be declarative, but also to pull inspiration from Jest. So, like, what does that mean? How do you have a declarative validation library that also is inspired by these testing frameworks?
So when writing unit tests, you actually do get quite declarative when not specifying the specific test logic, constructing mocks or whatever. But you have a very declarative structure inside that library specifically. So, for example, you have your describe block, and each of the tests is very much declarative, and it actually even tells you what it's supposed to be doing inside the description for the test. And then inside of it, for example, if we use expect, you have ingest, you have expect to be something, or whatever metric you have there. So very much of what you do inside your unit test, other than the construction of the test or construction of your functions, is very declarative. So this is the declarative part that I drew from unit testing to Vest.
Gotcha. So, like, the expectations that a whatever
Hmm.
whatever your testing framework setting is declarative itself. Yeah, I think that's probably a good way to put it. I think a lot of
Yeah,
people, yeah, they
exactly.
when they're thinking about their tests, they're like, no, I do all this work to get it set up. But it's like, but the meat of your test is just like, is blah, does it look like this, right? Like, yeah. So once that kind
Exactly.
of clicked for me, I was like, oh, I get it. What got you kind of interested in this space, and how'd you get on this path?
So about in I think 2015 or 2016, with a previous employer, Fiverr.com, we started writing unit testing for our JavaScript tests, and we also had many forms in the website, and we didn't know how to deal with them. We had to write duplicate form validations. We had validations that did not match in the client and the server. Um, it was really hard to maintain because many form had many interdependent fields. And when we started writing the unit tests and I started learning about the structures, back then it was Mocha, I saw a pattern that aligned exactly with the way I thought about unit testing, because basically, as I said before, um, we have this big testing suite. Inside of it, we have different tests that what we actually want to do is check that our functions match some expectation or some assertions. And if we take the same concepts into the world of form validation, well, basically, that's exactly the thing we're doing. We have a form which could be described as our suite, and inside of it, we have some different assertions that we want to run our data against. So we're not testing functions, but whatever we are testing is pretty much or can be pretty much the same structure.
Gotcha. Nice. Yeah. So was there was the goal just to make to kind of ease the cognitive load of having to think in two different ways, or were you trying to, like, set out and create a module that could be used like in tests and also form validation, or how did you, like, what was the goal when you started?
So when I started writing Vest, or actually it was the predecessor of Vest, it was called Passable. I
Hmm.
recreated it 2 years ago. But I mostly thought, well, it could be an interesting idea to experiment on. And the more I started, the more I wrote it, and the more I built the framework itself, I realized there's something in there that's easier to understand and way more expressive than anything I've done before. Because we have, when writing form validation, we never even know where to stuff our validation logic, because it can be inside our change handler, it can be in a third party library that's completely separate from our feature and is unaware of our feature. It can be a mix of both, and it's really hard to maintain going forward. And the more I wrote Vast and the more I used it, I actually realized this is sustainable and actually usable in the long run. And that's what made me go fully into Vast and invest more time in it.
Nice. Can you give an example of one of those, like an external library that would be needing to do validation on a form
So I
or an
don't want to
endpoint?
talk about any specific form validation
Okay.
library because, well, I think most of them are actually great and they come to solve some real problems and they have some real valid solutions. And I mean, they've proven themselves to be very useful. I mean, they're being used by millions of developers.
Yeah.
Um, but I'm going to describe, I think, the three types of form validation libraries that we have today, and I think Vest is the fourth
Oh, cool.
type of form validation library. It's like a new breed of form validation libraries. So we have the original or the basic, the most basic form validation library, which is actually not even a form validation library. It's more like functional validators. So we have a function like is number or is email, and we just run some data against that function. And you don't get much control over the flow of data inside your feature, or you don't get any structure actually. And I think a second type of form validation library is something that's widely used, which is schema validation libraries, and we have many of those, usually used in the APIs, but I've also seen it used in the client. And basically, what you have there is you specify some structure that you want your data to follow, like, for example, a JSON schema. And then you have the username has to be a string, and the password has to be some kind of validation function, and whatever you have in there. And this is really good and really, really useful, but mostly when dealing with validation on the server. But how do you deal with a schema when the user types, for example? And what you end up doing either directly or indirectly with the library is whenever the user types is just trim away or remove parts of the validation that did not that are not related to what the user just typed. For example, the user typed inside the username field. Also, the password is a part of the schema, so you don't have much way of controlling which field is getting validated. And then you have the third way, or the third type of form validation libraries, which is by far, I think, the mostly used today, which is UI libraries or UI utilities that manage form state. And these are usually tied to a specific framework like React or Vue or Angular. And you have a library that can manage the form state and also the validation. And usually, what they give you is either components for inputs, or they give you some references that you have to put on your element or event listeners. And they are really good, but they also come with some cost because um, first they are tied to one specific framework. So if you have multiple apps, for example, you have multiple apps on the same site, or you use like micro front end architecture, whatever that is today, but you use micro front end architecture with multiple frameworks, you cannot share between them. And also you have some third party library handling your UI and taking some control over your UI, and then, well, you have to deal with it. And the fourth type is basically Vest, which I think is unlike all the others. And there are, I think, 10,000 validation libraries on npm, but I think Vest is one is just there's just one of those, which is a validation library that only takes care of validation. It thinks about your form and feature as a whole, and it is very much inspired by unit testing and takes it to the next level with a stateful validation.
Gotcha. I guess, yeah. Can you go into that a little more in what you mean by how it only cares about validation?
So most of the UI libraries that manage validation or form state actually take care and handle your form state. So you give them the inputs and they save it, and they also give it back to the UI. Most of them, not all of them, of course. But Vest doesn't care much about the data. Of course, you pass it the data to be validated, but Vest doesn't care much about the shape of the data, such as in schema validation, and it doesn't care much about what's ever happening in the DOM. It only cares about the validation, and then you can do some creative stuff because you can express your validation regardless of what's happening in the DOM, but still you can have a lot of control. So you can write multiple tests for the same field because it doesn't have to follow some structure. I can have multiple tests for username, and then as a result of that, multiple errors presented to the user just because we can write multiple tests and for just in a single field.
Gotcha, gotcha. Yeah, that makes sense. And I feel like that delineation is pretty clear to me when we're comparing them to like the UI libraries that track state or like schema validation libraries. But how does that differ from your first type, like the functional type? Because those feel pretty um, like conceptually disjointed. Like those really are just caring about validation too, in the typical sense, I would say.
So these are disjointed, as you mentioned, and basically you can write whatever it is and whatever you want, and you can actually even use them with Vest. Vest doesn't care which assertions you use, even though it does come with a lot of assertion libraries or assertion functions, but what Best does give you is specify some sort of structure and some sort of internal state for validation. So it doesn't care about the state of the form, but it does care about the validation state. So for example, if I type, I don't know, if I type inside the username field, and I go out then to see if the username is already taken, and then the user types in another character, Vest will cancel the previous request and then only show the validation for the new request. This is one example. Or without a tool like Vest that can handle multiple fields, it will be very hard for me to make tests for fields that are cross-dependent or interdependent. For example, password and password confirmation. And when all the tests are disjointed, yes, you get all the control, but you have to assemble everything yourself.
Gotcha, gotcha. So is it fair to say then that the advantage that Vest is really like leaning on over those functional, like the super old school type, is that it's tracking and aware of the validation state itself, even if it doesn't care much about the form state.
Yes, exactly. Exactly.
Gotcha, gotcha. Yeah, cool. Okay, that's a super clean way to put that. Nice, awesome. So, yeah, you talked about cases of like asynchronous logic or validations that have to call out to a server. Does Vest provide a lot of utility for like async calls that may need to be debounced or something like wait until a user or stops typing for some amount of time? Does it have like those kind of utilities baked in, or do you have to like bring your own from Lodash or something?
So the most I've seen today being used and being needed by Vest is not debouncing, because debouncing is really much, it's very much tied into business logic and how you want your user to experience the website or the application. But Vest does give you some utilities for handling not just async validations, but validations as a whole. So for example, I told you can write multiple tests for the same field. So for example, let's go back to the username example. If I have three tests for username, for example, one, username must not be empty. Second, username must be more than three characters. And third, username is already taken, for example, on the server. Vest, first of all, allows you to specify, do not run the async test unless all the previous tests for that username field already passed. So this is one. And secondly, as you mentioned, these async tests can be very costly, and we don't want to just go out to the server for every keystroke type. And we don't always know whenever the user is finished. So what one thing Best does give you is memorization of async tests. So, for example, if you run a validation for a username and then the user regrets, types another username and forgets about writing that first username, or even just hits backspace, if we have the result for that previous validation, we will not even go to the server to go to see that same result if we already have it. Does that make sense?
Yeah. So if they end up typing the same name that's already been typed, they get like a local cache memoized version. Nice, nice, very cool. Yeah, are there other good examples of that other than like checking for a username on a server that might be pertinent?
So this is the most used one, and it's common enough to actually have to write a utility for it. But basically, everything that has to do with either heavy calculations or going to the server, like email or username, captchas, if you implement your own, whatever it is.
Gotcha. Yeah. I mean, I can think of a handful of others
Mhm.
potentially, but that's cool. Are there other utilities like that Vest has kind of like become interested in, maintaining specific logic for this use case?
So the other main utility that Best maintains is the each utility, which is basically allowing you to specify dynamic fields. So sometimes the user is in the control of the fields being presented or fields being sent because they can add items, remove items, and you cannot know in the beginning which fields are going to be validated. So you cannot specify them inside of the suite, hard coded. And Vest has an each utility that allows you to basically iterate over an array, specifying the different tests that every item in that array has to pass.
Oh, gotcha. Interesting. Yeah, very cool. Is it tricky? That kind of leads me to another interesting point. Like, so there is a list and there's dependencies between those items. Like, validation is concerned about the state of one to test if another is valid. Like, say you can't have two items, I don't know, with the same name, for example, in your list. Can you set up that kind of validation in Best?
So the nice thing about Best is that at any stage within the validation, you can check the intermediate validation result. You always have access to whatever's happened before inside that current suite run. So if I run
Got it.
my validation, my async validation, and the third test is already matching something that I've seen before, yeah, I can do whatever. I mean, I'm in control over there as a developer.
Yeah, I think that kind of paints a pretty good picture for me. One question that did come to mind as you were talking a little bit about your inspiration and having to maintain different tests, server and client side, was like, what does Vest have support for kind of getting these same validations running in a JS or a Node environment in the server?
So one of the main things that I think were key to me and very important to me when building Best is that it has to be able to run on the server the same way that it runs in the browser, so you can share validations between the client and the server. Because validations just on the client are not good, and validations that don't match with between the server and the client can be even worse, because the user will be able to do something that they can be told later they're not supposed to be doing, or versa, even worse, they'll be able to do something that they shouldn't be doing. So as much as you can, I prefer having validations both on the server and the client matching, and you can just run your form validation on the server. It does require one slight change, and you have to unregister your suite between each request, because otherwise you'll have a validation suite state being retained between requests. But other than that, I mean, the same Redux state on the server, I guess. You shouldn't leak
Yeah,
it.
yeah. Gotcha. Nice. I guess is that how involved is that setup? Like, say you've got a typical app that's running, JavaScript in some form in the server and client. Like, how hard is that to set up?
So creating a best suite is basically running the create function with a callback. That's all it takes. And what you want to do is just you get a suite object and a function, and
Mhm.
it has a property called reset. So whenever you're done validating your suite, you call that reset, and you're all set. Actually.
Nice, nice, very cool, very cool. Um, yeah, so I guess kind of in that vein, like say you are a React dev and you're using some other validation library right now, and you're feeling some frustration about it. Is there anything in particular that you might uh, or any particular problems that devs might be facing in their other validation suites that they're using that you would motivate that or that might motivate them to check out Vest in particular?
So first of all, my advice to any dev listening to it, um, if it works for you, don't switch. You'll hate me for switching. You'll hate the world for switching. Don't switch if it works. But if you are having a hard time using your current validation solution, then you should probably try out Vest. And by having issues working with your current validation solution, I would usually talk about bloat inside your feature code. So your feature code is spaghettied with a lot of validation code, and every time you come to touch it, it's really hard to read or really hard to rewrite, or even sometimes when making refactors, you have to rewrite everything just to account for the new feature or the new field. Um, and if you want to have some more order inside your validations, then yeah, VAS is probably the right solution because I didn't mention it explicitly, but VEST is a validation suite that's completely separate from your feature code. So you can see everything in a glance and you don't have some validation logic lying around inside your feature code with the user interaction.
Gotcha. Yeah, yeah, yeah. Very cool. Very cool. Is there yeah talking about devs that have these bloated validation layers and like tightly coupled code and you change one thing and it breaks seven things, is that like a common pattern that you see out in the wild, or is it something you've seen in past lives, past experiences where you have this really hard to manage tightly coupled validation code?
It's not just something I see out in the wild. It's something I've been doing for years before writing Invest. I'm to blame for it as well. And yes, unfortunately, one thing we don't think about when writing our features is the validation. And this is sad because the form inside our feature is usually the gateway to the server, and it is the contract between the feature and the server, and the reason we actually built the feature to begin with. And this is the most likely part to break because this is, well, the most interaction heavy part of our app. This is where our users make the most interactions. They type, they touch, they click. So if something breaks, it usually breaks there. So I think it is worth investing in a solution that's also reliable and helps you maintain some order.
Yeah, totally. Did this method of thinking where you're kind of I guess to your point of like validation is the closest to the user and pivotal to the function of the app, right? Like did that kind of lead to the API decisions that you made when designing Vest, like that developer experience?
So the most important point or the most important idea I had to retain, and I'm reminding you, I started writing Vest or Passable back then,
Mm-hmm.
drawing inspiration from unit testing libraries. So
Right.
my first ideal was to stay as close as possible to the world of unit testing.
Mm-hmm.
And most API decisions in terms of structure, syntax and terminology is drawn and should be as close as possible to unit testing.
Gotcha. Did you find something about unit testing to be particularly intuitive, and that's why you kind of chose it as the baseline, or was it more of like, we're doing unit testing anyway, let's try to mirror it?
Um, so I thought the case of unit testing just makes sense when speaking about form validation for the same reason that I mentioned before. You have a suite of different functions that run against some predefined tests that match some expectations. And I mean, if that syntax and that structure works so well for testing your code, why wouldn't it work so well for testing your data or forms?
I'm kind of thinking about that as well. Like, I feel like seldom am I writing, in my unit testing framework of choice and struggling with the API. Like, it always feels pretty, like it's doing what I want it to do pretty painlessly. So I think I agree with that decision. I was just curious, like, if that was a conscious thing or if you've been thinking about it ahead of time. Um, but yeah, that's interesting to hear. For other people, kind of like interested in this space, writing developer tools that are kind of in this tier, like even unit testing frameworks, validation libraries, anything like that, where you're like tools for devs. Is there any advice you would give them?
Or not just validation or unit testing, any library at all, I think.
Yeah, really
um,
anything. Yeah. Hmm.
yeah, because I think this is one of the most interesting parts of software development, because as engineer we rarely, I think, solve hard engineering problems, but we usually write code for other people to use, and we solve human engineering problems. And it's a tricky one to get right, because if you do something wrong, especially in the world of open source, it is immensely difficult to fix later, because more often than not, whatever you add into your API, whatever it is, library or framework or tool, it will already be in use by somebody out there. So you have to get it right from the get go. And I think there are three things and three goals when writing tools for other developers, APIs for other developers. And first of all, the tool you write has to actually work. It has to do whatever it promises to do, because if it doesn't, then it doesn't even have a right to exist. It comes to solve some problem or some or answer some need, and if it doesn't, well, it shouldn't exist at all.
Yeah,
But
sure.
the two, yeah, but the two others are more important in terms of design. And for a second, it has to be easy and intuitive to use, and this is a big part, how to make something intuitive. Maybe I'll get to it. And also, it has to be safe to use and hard to abuse. You cannot let your consumers harm themselves, or it shouldn't be dangerous for them to use. And when you build your API, you're teaching your consumers a language or a pattern. You don't want to have them go to the documentation every time they want to use your library or tool, and instead you have to be try to be at least consistent. Use similar naming and terms, and if you can, also build on top of existing knowledge. For example, as I did in Vest, I try to build on top of the developers already existing knowledge of unit testing libraries and frameworks, so they have a very easy learning curve when trying out Vest. It's so similar to unit testing libraries, actually, that if I just hook a CLI to it, Vest can be used as a unit testing library. So it's pretty cool. And and regarding the tool being safe to use and hard to abuse, I think you have to build it and design it with safety in mind. So you have to. Yeah, sometimes you do have to allow your consumers do dangerous things, but if you do, you have to let them know it's dangerous. So if you think about, I don't know, React, they give you dangerously set inner HTML. You can't use it without knowing you may be doing something harmful. So it's really important.
Yeah, gotcha. That's a good example, probably, of a
Mhm.
dangerous, like a dangerous kind of surface point in an API. What's an example of something that's like easy to abuse in APIs that you're trying to avoid when doing API design? Like, how do you make your you know surface hard to abuse?
Um, you can make the surface hard to abuse, and hard to abuse is doesn't necessarily mean do evil things. And I usually think people are good and try to do good things and have good intent,
Mhm.
but hard to abuse usually means doing something they're not supposed to be doing with your tool. For example, using internal APIs that are not a part of the documentation or the contract. And to make something harder to abuse, you usually have to think about those as well, because everything in your signature, even though it's not a part of the contract, everything exposed to the consumer, every perceivable behavior will be used by somebody. And then when you want to make some refactor, or when people start breaking because you made some change because you were unaware that they are going to use it, well, they abused it even though they didn't mean to. Because we're developers, we have magic powers. We can see code and we can use it even if it was not intended to be used.
Yeah, yeah. I feel like this is a point we've kind of landed on with a couple of our recent podcasts. Like we were talking about it with like the internal Vue APIs that Evan was having trouble like getting devs. Like the big libraries were using these internal APIs that nobody was really supposed to be using, so they were having all these problems. Like getting those libraries to upgrade. And yeah, that's an interesting point. And like, I feel abuse isn't like necessarily evil. It's just devs have feeling the need to like reach into the internals of something and use it in some way that wasn't necessarily prescribed or like the intent of the API.
Exactly.
Yeah. So that's super interesting. One, I guess, to this point of like all these things you have to keep in mind when setting out and writing an API, especially for an open source library, like you said, of like everything's got to be pretty tight in V1. How, say you're a new dev, you're interested in building tooling like this, like how do you get over the fear of messing something up? Like how do you get to V1? That just seems so scary.
Yeah, it's really scary. I remember releasing my first version of Passable in 2016 or 17, and well, it sucked. And it took me, I think, and just 2 days later, I realized everything was garbage, and I made a full major version change. And I actually did it to Passable 7 times until I landed on a viable API. And this what led me to actually understand the need of writing good API from the get go. But also fear not, because like everything in software development, API design as well, I think everything there is a trade off. You don't always know the right solution and you don't always have the right answer. And when you don't, just leave stuff out. If you don't have the correct solution yet, it may be okay. It took me 4 years to add a simple function to Vest, which is valid. Um, a validation framework that for 4 years didn't have the is valid function because I didn't land on the right solution from the get go and I didn't have the need for it yet. So if you don't add something, you will never regret for adding it. And it's always a trade off, and you are the domain expert in whatever field that you are building the library for, and you have to balance it.
Is it easy to maintain motivation for you, like when you realize that you've made some big underlying mistake to the API? Because I think it's a pretty common pattern. Like somebody's got a project, they're working on it, they realize they've done something fundamentally pretty wrong at a low level, and they're like, I don't even want to keep working on this anymore because there's like how do you overcome that feeling?
So when you are small and people don't know about your library, well, there's no harm done. I mean, you can always fix it, bump another major version, and that's okay. Nobody uses it yet. When it's big and there are real implications and people are breaking because of your API decisions, it's a bit harder. And there's not much to do other than offer support, update the documentation, and try. Even if you have made some bad decisions in the past, try to fix them by adding alternative APIs or other solutions to your library or to your tool, so people have the choice, and add, I don't know, a deprecation notice in the documentation for whatever it is that you're doing. And also, if it causes some errors, make sure these errors are very descriptive. So for example, errors are kind of documentation too, and each and every error, especially in a bad API or badly designed API, should include at least some of the following: what went wrong, what happened, what could be the cause of it, maybe alternative solutions or possible solutions for that problem. And if possible, even a link to the documentations. And if all these exist inside your error message, then yeah, you made a bad API decisions in the past, but you are allowing your users to easily fix them.
So I see Vest is on 4.1.1 right now. Like that's master, I think. How do you decide when you have like a flaw large enough to justify a major version number bump?
A major version is usually, I don't think about it as like a bug fix, and it has to
Sure.
be more strategic. When I want to add like a major API change, I also want it to come with like a bag of presents for my
Yeah.
consumers. So a
Sure.
lot of many new cool features that I want them to use and actually promote them to use the new version. um, so I can't point the finger or put the finger on one specific on just a specific indicator that a version a major version should be bumped. But usually when I accumulated enough improvements and I've made a decision that some previous decisions that I've made are not no longer good or do not satisfy the current needs of the library, then yeah, when all these are met, I'll just update the major version.
Gotcha. And I guess, yeah, do you kind of adhere to the semver practice of like in those major versions you can introduce breaking changes as long as they're, like well broadcast?
Yeah, I try to abide by Semver.
Yeah, totally. Yeah, just
Yeah.
kind of curious how you thought about that. I guess more broadly, when it comes to like maintaining an open source library with lots of eyes on it, like how do you find that experience? Is it stressful? Does it energize you? What's that like?
I really enjoy it. I mean, it's much better than having nobody look at what you write.
Hmm.
So this is actually the hardest challenge. I mean, I remember when writing my first open source contribution, wherever it was. I mean, and writing my first library. Um, I was like, okay, now everybody's gonna laugh at my ugly code and my stupid code. And for I don't know, a year and a half, nobody even cared, which was the biggest hurdle to overcome. And now, when I actually see the star count going up and the user count going up and the downloads going up, I'm actually energized by that. And when I get an issue, a GitHub issue, either or even on Discord, somebody asking a question or saying there is a bug or something doesn't work correctly, I'm excited because, well, I'm doing something that's helping people and they care enough about it to actually come report back to me.
Nice. Um, it's interesting that you bring up Discord. How do you find kind of managing and curating a community for an open source project, like via a Discord server?
I'm
How does
terrible
that
at that.
feel? Yeah, it's tough.
I'm
It's
terrible
tough.
at that. I'm more of an engineer than a community leader.
Hmm.
But I'm trying. I've set up different rooms and channels, whatever it's called on Discord,
Hmm.
for the different purposes. I added the link to the documentation of Vast, and sometimes I see new people dropping by, but I'm not really good at promoting it in the community.
Gotcha. Yeah, I feel like I've found just through personal experience and hanging out in other like kind of dev tooling communities, you end up with a lot more of the same question being repeated in those kind of like more chat-esque channels. Um, I don't know if there's any interesting takeaways here, but yeah, I feel like there is much more of a community management piece happening in those like more real-time communication platforms than something like GitHub, where it's a little more form-like and you have issues and
Mhm.
it's like more curated. Um, so yeah, was curious if you struggled with that at all. But I'm glad that you find it exciting and like it motivates you a little bit.
It
Um,
does, totally does.
As you were talking, we just had Ash Jeffs on. I think his recording was yesterday. He's the creator of Benthos. He was talking about maintaining open source and the importance of avoiding burnout. Just because, like with a lot of other projects, interests, there's like physical limitations with kind of web development and open source projects. You don't really have, like, as long as you are awake and have internet, you can work on it. So I guess what are some strategies around avoiding burnout that you take?
Vest is not actually the only project I maintain. I have a few, and Vest is not even the most popular one that I maintain. It is in terms of star count, but not in terms of usages. I have a React component for an emoji picker that has like thousands of users in different apps, and I always constantly get new issues and bugs because this is something people actually see on their web page. So it's much easier to detect bugs. And I've decided that I'm unable to keep maintaining it because if I would maintain both this library and Vest at the same time, I would, as you said, burn out. And what I decided to do is give it out to the community. So I'm at the moment mentoring a couple of new developers into taking the project full time. And this is the way I see basically reducing the amount of responsibility and time you have to allocate to all of your projects and just focus on whatever gives you the best energy and most motivation, which at the moment is Vest.
Awesome. Yeah, very cool. Awesome. Yeah, is there anything that you would like to plug or want to point our listeners to?
I'll just say that if you're interested in trying out Vest or even contributing to Vest in terms of documentation, code, examples, because I didn't mention it, but Vest can be used with any framework out there, any UI framework. So if you want to contribute to Vest in any way, feel free to drop in the GitHub or the Discord chat. I'm trying to be available there, and I really, really enjoy any traffic going in.
Awesome. And we will include those links in our show notes as always. So go check those out. Thank you so much for coming on. And yeah, we'll see you around.
Thank you for having me.